All right, this is like, I'm kind of all twisted over here because this is plugged into the wall because I'm low on battery. So I'll just do the lecture like this. Okay, we're live. I assume somebody say something with your microphone so I can just make sure my sound is working.
Well, if it makes you feel any better, I went back to my capstone today
Yeah,
to revisit it. An error right off the bat. I'm like, oh, God.
really? What
Yeah.
was it?
Well,
Some
actually,
like,
what I did was I updated because I was using like React version. I don't even know what it was. It was whatever 2 years ago was. So I updated like the React version and the React DOM version
oh boy, yeah.
and my Node because that was outdated. Um, but it's something to do with the hooks. So Joey's
What?
gonna get together
Okay,
with me over the weekend and see if we can figure it out.
yeah, that sounds good. Uh, that's what React version was it? Was it like major versions of React?
Oh yeah, it was. I want to say it was like maybe 14
Wow, and
or
they're on
14.
who even knows by now.
Yeah.
Well, uh, okay, I just had to assign the homework for tonight. We are all set with that. The homework for tonight is to use one of the techniques we will talk about in class to uh, intercept an error in some sample code. So I guess the first thing is, has anybody had any trouble with the free code camp array exercises? If you've tried those, like just let me know because those are like really that homework. I like it's sort of honor system, like just post a picture of your progress. But I'm really trying to push those as good ways to practice. It's not, all these crazy concepts that we're throwing at you in the lectures. It's just as well, it's more necessary than a lot of the stuff we did yesterday, but it's more necessary than, a lot of the stuff in general, because you really do need to train your eyes to see code. Dominique, do you want to share your screen? Would you like to do that?
It's not
Okay.
more of a sharing screen thing, it's more of a comprehension thing. I really
Okay.
don't have a clue of what I'm doing, to be
Okay.
quite
But
honest.
you are able to do
Yeah, I'm able to get there and
to get
everything.
there
It's
and to,
just trying to get
okay.
the code to go through and to get to the next page.
Well, here's what I would recommend. Um, why don't we do a session like in the weekend or anytime you want, like where we just do, because I think like it's not like I'll try, I can have a style where like, basically I can give you hints that are going to give you a little nudge in the right direction and sort of steer you away from, some wasting time on something that's sort of a dead end. And I think like any of the instructors can easily do that. So I would like reach out to me, reach out to anybody and just say, I want to do some exercises and I'd like to have a mentor there do them. I think that that's a fine way to use some one-on-one time. So I recommend that and that's if you're having trouble, solving the puzzles. So yeah, Susan, you've been able to get through some of them, but you're getting stumped on some of them. That's fine. And it's fine to post one on into the channel or into a chat, or say you want to work on it one-on-one and you just like some hints, and some guidance while you're working on it, and then share your screen and do it in that context. I think that would be good. The only other thing I want to say before we get started is like, we have so much, I mean, there's so much material we're throwing at you, lecture wise, the slides, there are exercises, there's homework. Some of it's pretty tricky. The free co-camp exercises, there's a lot of that. The readings, there's a lot of that. Those are all suggested readings. Those are not, official homework or anything. And then the list of books that Karen's posted, those are all books long. I mean, this is a ton of material. And I really just wanted to make sure, because I realized yesterday that some people might have the impression that like what we're saying is do all of it. We're not at all saying do every single thing we're sending you. We're not saying read the reading and finish every single homework and do every single exercise on Free Code Camp and all the supplemental books. The reason we're throwing so many of these things at you is really because everybody is going to respond better or worse to different kinds of learning. Some of you are going to see one of the books and really like the style of that author and say, hey, I really can, this person's communicating in a way, I really get it. They're explaining this stuff in a way. The official reading I'm assigning, it's very academic. There's a whole lot of kind of like details and technical details, which is why it's kind of extra stuff. If you're really curious about what the real guts of this stuff are, that's what some of the readings we are recommending in the Eloquent JavaScript book are good at. They go into tons of kind of like detail, which is not really necessary for the craft. And then, the Free Code Camp exercises are like the training that you need if you kind of like your ability to see little details in the code and your ability to not make typos on the keyboard, if that's where you're kind of like struggling. So like, yeah, I mean, Latonia, I think you're kind of on the right track where like we'd recommend if you're not finding success with one of the methods, try the other ones. Just try the start of like one of the books, try to do some of the exercises. Free Code Camp is one of the best ways because it really just gets you in the practice of doing it. And I think, for a lot of people, this, one misconception I think some people might still have is that programming is just like this difficult mental effort and like, or difficult, like mental, not effort, but like trick, like some kind of human trick that you do. And either you're like a programmer and you can do this trick, or you can't do the trick. Oh, and then I guess that means you're not a programmer. And that's not how it is at all. Programming is a craft. More than anything else, it's a craft. And what that means, a craft is something that you can only get good at by doing it a lot. You can only get good at it by doing it a lot. And the good news is that if you do it a lot, you will get good at it. It's a craft. That's what it is. So whatever helps you get into doing it, and obviously the capstone is going to really be good motivation because it's going to be a large project. You're going to be reaching out for help. You're going to be pushing it forward. And that doing a lot of it is going to be really good for your learning. But exercises are really good for your learning. Anything that causes you to do more programming is the right way for you to learn. That's really kind of my speech for today. So yeah, I think like, yeah, it takes a long time, and the only way to get good at it is going to be to put in that time. That's really what it comes down to. And as you saw yesterday, a lot of this stuff, I still can't remember a lot of the details of some of this stuff I'm teaching. And that's okay, because the stuff that you have to do in your job, in your capstone, you will get good at that stuff. And the other stuff, maybe not, and that's fine. So we're trying to give you broad exposure to all this stuff and a broad set of resources, but your path of learning is just the path that is going to work for you and is allow you to just continue to learn little by little over time and just move in the direction of mastering that craft, because that's what it is. So, all right, speech over. I should have put like slides for that, but that's the speech for today. Let's do some slides. Okay. Transcript. I think the transcript is working. We're on YouTube. We're all ready to go. Okay. Oops. Actually, let me make sure I have my VS Code window. Okay, in a Scratch file. Yeah, so I'm gonna type some stuff into just a Scratch file. You can create this anywhere you want. Fetch the latest if you want the homework, and one of the examples is a pretty big chunk of code that I put in one of the files. So you know, do your thing to get the latest code base. I have some extra Scratch files. I'm just gonna leave them here. But if you have any problem when you click this, you're definitely gonna want to control click, discard, and then try it again. And then oh, because I have changes, there's no open in Visual Studio Code. Where's that button? That's such a nice way to just do it. What about here? Maybe we just don't have it. That's a bummer. What about file? No, repository. Ooh, look at this. Okay, so even if you have changes, we just made a discovery. Even if you have changes in your code base and you want to leave them, and you want to, you know, be sure to try to fetch the latest. This should say fetch, and you know, there will be new code in here. But even if you have some changes and you're looking for where's that button to open the right folder, you can go to repository at the top and then open in Visual Studio Code. There it is. So it's always up here if you have changes. Okay. And I was just, just messing around in the Scratch file. I'll clear that out. Whoops. And we're ready to go. Well, I'll clear out my terminal and just do a fresh one. So control, I found the W7D3 errors folder, control click, open an integrated terminal. And we're in the right folder. We're ready to go. Okay, I'm going to do Command Tab to jump between my windows back to Chrome, and we'll do some slides. Okay. Okay, we got some more stuff about objects and arrays. We're going to talk about JavaScript errors, those throw new error. What was that? There was that throw new error code. There was try and catch. And finally, these ways of working with errors that JavaScript produces, which are like things that can cause your program to crash or end. But if you know how to work with them, they can also be used to make your program safer to extend. And you can basically like choose what to do whenever you get any kind of different error. Unless it's truly a showstopper error, you can handle it and do something with it. So we're going to go into that today. Okay, here's some extra goodies about objects first. In newer versions of JavaScript, there's not only can you make so here's an object, and it has a property called log, which has the value of an array. This array value is assigned to the property log on this object. It also has a property called latest, which is defined in this way. Now, I'll play around with this a little, but this is what's called a getter. This is a newer syntax that doesn't work in older JavaScript, but is, ooh, I don't like that indentation. Okay. This is a newer syntax. So let's say the older syntax, we could define a method. We could say latest : function. And as we've seen before, objects can have keys that are either values here. They could be other objects and arrays nested here. They can be functions right inside the object. And these are called methods when they are functions that are assigned to properties of an object. And in this case, if we log latest, it's going to return the string version of latest. So this is actually the same thing as calling a special method that's on everything, I think everything in JavaScript, called toString. When you call console.log and you give it something that's not already a string, this actually happens behind the scenes. So this is just a bit of trivia that everything has a way to print it as a string. And that's why you see something like this, function latest, rather than, rather than like this text literally, is because the function's toString method, it returns that. Oh, wait, it doesn't. Never mind. I'm wrong. The function's toString method actually prints out the whole function. I'm totally wrong about that. So why does it choose to render it like this? I'm not sure. Anyway, it has a toString method. Everything has a toString method. We're starting today off on the wrong foot. Wonderful. Anyway, that's not the point of this lesson. That's some trivia that I forgot to put in another lesson. Everything has a toString method that converts it to a string if you want. What I'm trying to get at here is that this is a function, object.latest. If you just log it, it's not running this function. It's just saying, here's a function. Here you go. Here's your function. It doesn't do any of what's in the function. It doesn't evaluate to whatever the function returns. In order to do that, we have to run the function. We have to put another set of parentheses, empty parentheses right after it to say run it. It doesn't take any arguments, so the parentheses are empty. So if we call latest, it will do whatever's in latest. So latest says if this, remember this, is the object, because we're running it as a method of this object. So this is the object. Wonderful. Our favorite little part of JavaScript. If this dot log, which is going to be, because it's a method of this object, it's going to be this object dot log dot length equals is 0. It's going to return nothing. Otherwise, return undefined. It's going to say there is no latest item in this log because the log is empty. If the length is 0, it's empty. It returns undefined. The if block then ends right here. Because it's all on one line, you don't really need these braces, but I like to keep them just to make sure that I don't accidentally I like to put the braces on every if statement. I'm a bit of a obsessive compulsive person, so I just need it to be neat like that. So we're done with our if statement. It hasn't returned yet, so it continues. It returns instead this dot log, which is an array, and it pulls the item out of that is this dot log dot length minus 1, which is always going to be the last item in the log, because the length is the number of items. It's 3 minus 1, that's 2. Index 2 is the third item. And you'll see this pattern a lot whenever you're doing the last item in an array. It's array.length minus 1. So this dot log dot length minus 1. It would be the same if we said, if we formatted it like this, and if we put an else. In this case, it's the same behavior because it's returning one in one case and returning the other in the other case. We don't technically need the else because if it returns the first one, then our function's immediately done. It's done running and it won't even get to this line. So that's why this kind of shorter version only has 2 lines. If it's this, return this, and then assuming that it hasn't returned yet, return the other thing. So if we call that, we will get C because we are pulling it out of the end of our log. Now, a getter is a newer kind of fancier syntax way to do this. You can say instead get, the word get, and then no colon function or anything. It says get latest, and it's this just immediately has some parentheses here. And we saw this yesterday with that weird class thing, blah, where it's like constructor, and then immediately the parentheses. It really is a function, but it's this kind of weird syntax where it's only the name of the function. There's no word function. There's no little arrow thing. But because of its context, because it's get this name, parentheses, and braces, it knows that this is going to be a function. And what this does for us is it will still run this function, but you don't have to put the parentheses. Just by accessing the property that's called latest in this object, you're going to run the get function. So this is one of those kind of JavaScript feature envy things. The JavaScript committee saw that some other language had this feature, and they were like, we want that feature too. So they added it, and now you have to learn it. So that's how a lot of these things go. But in any case, just by accessing the property, it will find that, hey, there's a getter for this property. And a getter is just a function. It's going to return, it's going to run the function, and this expression will now become what this returns. So it's going to be this because the log is not empty. Now, in a very similar way, there's an object setter. So, whoops. So we could say, here's another object. And we can do the reverse kind of thing. We could say, instead of when we evaluate this property, or when we evaluate the property of this object, it automatically runs a function. We can say, no, we want to run this function when we assign to this property, when we use the equals to assign a value to this property. And that's called a setter. Same pattern, but it's the word set, and then the name of the property, which is sort of like a weird function. And we're also using the odd this thing, because that's how you access. This is actually probably one sort of legitimate use for the this word. There's no other way to really look at a sibling property on this object when we're in the context of a setter. So you pretty much need to use this here, I think.
Can you make it bigger, Gus? Karen asked in the chat if you could make it bigger.
Is that big enough? I think we can probably make do this. Okay. So when you assign to this property, you're going to run this function thing. It's going to access log by using this, because this is in the same kind of it's in the same kind of execution context and all of that as if it's any other property on this object. So this is this object itself, and this .log is this thing here, and we're pushing each time we set assign to this. So the way this works is we could assign a couple times over the course of our program. And then our log is actually going to have all three of these in it. Even though we're assigning current and just writing over current is this, now current is this, now current is this. Current really isn't a property. It is a sort of a fake property that every time we assign to it, we add something to this dot log, sorry, to this dot log. So so now if we log this, or if we print out this language.log, we're going to see three things in it. Even though we're not pushing down here, we're pushing here. And you can combine these. So we could say, we will add our getter back to here. So we could say we have language and set language. And we will rename this to be a little easier to understand, language history. And now we sort of have, oh man, this is getting long. But we sort of have a property now, which we can use like any other property. But we, as a side effect of just using this property, just accessing it and assigning to it, we can also save the history of everything that it's ever been. So if I said language, whoops, I'm going to call this object now because you can't have language.language. So whatever our object is has a language property, and it's this magic setup so that it has a side effect. Just using the language property has a side effect of saving every change to the language into this special language history thing. And then we could say object.language, or we'll say console.log object.language. Now it starts as undefined because the length of this will be 0 the first time. And so we're going to return undefined. Then if we, let's set the language a couple times. Object language equals English. Object language equals Chinese. And then we'll say console log object language. And we're going to get the last thing we set. So it will work just like any other property of an object to the outside world. But as a side effect of setting it, we will also have preserved like this array that has every change that we've ever made to that language too. Language.log.push. No, this is, I renamed everything, Mel, sorry. I'll paste this example in the pasted code as soon as I make sure it works. So yeah, sorry. So we log two things. Well, actually we log three things. First, we log it right away. It's undefined. So we haven't set anything. We haven't assigned anything to this property on the object yet. Now we assign to it twice and we log out the language property. It's going to be, just as we kind of would expect, it's going to be the last thing we assign to it. It's CN. But as a side effect of assigning to this twice, we have also written to some kind of history log here, and we can see every change we made to it. And all of this code just basically achieves that result. I don't know, this is a bit of a contrived example. I don't know where you would actually want your objects to remember every assignment to them. But if, there might be a case you want that, and this would be an elegant way to do that. The rest of the program doesn't have to care that there's a log, and yeah, you can you can have it behave just like any other property. But in here, I guess what I'm saying is that this doesn't have to be just, oh, save a log. This could be anything. You can have it behave like a property, or you can have it not behave like a normal property with both get and set. You could have it console.log something as a side effect. You could have it be a booby trap that like messes up your whole program or makes an API call or something like that. This could lead to some very scary stuff, even because like somebody's just like, well, I'm just setting a property, aren't I? No, you're actually running a function, and who knows what it'll do. It could do anything. The best naming convention. How do you know the best naming convention to use? I'm sorry, Latonia, that is like the hardest problem in all of programming. So you don't know. You will have difficulty with it because it's like the hardest problem in all of programming. There's a famous saying, there's only two hard problems in programming. One is cache invalidation, CACHE, cache invalidation. And the other one is naming things. There's another variant of this that says there's only two hard problems in programming: cache invalidation, naming things, and off by one errors. Does anyone get it? Okay. It's because I said three things, yeah. And we didn't subtract one from our list, from our number of things. Yep. But yeah, off by one errors. That's another thing that's like where we forget to subtract one from the card row that the user put in to turn it back into an array index. That's called an off by one error. And you're probably going to have a couple of those while you're working on your capstone. Sorry in advance. Okay. All right. Enough of this getters and setters stuff. I just want to, they are newer. They might be useful. I don't really ever use these for stuff that, yeah, but I think that might just be a coincidence. I'm not sure. Another thing is, this you definitely want to know about. How would you remove a property from an object? So here's what I mean. If we go, and I pasted that code in the pasted code channel, if you'd like to run that example yourself. Why does this thing always scoots it over one space? All right, okay. So like, let me just go into Node for a second, and I can do let x equals a is 1. The key a is the value 1. It's an object we're assigning to x. So we have x. We can do x dot b equals 2. And we've created a new property inside the object x. We've just made a brand new property called b just by assigning to it. Well, how do you get rid of that? How do you do the reverse thing? How would you turn b? How would you get rid of b? Well, one thing people could say is, well, JavaScript just kind of considers a variable that you haven't defined yet to be equal to undefined. So we could say x dot b equals undefined. And it's like, okay, well, b is no longer defined. The problem is it still knows that there's a key b. It still remembers that there's a key b, and it has assigned it this value undefined. So once you're in the context of properties of an object, there's kind of another level of existence. It's like it isn't defined, but it does exist in this object. And if you want to totally get rid of it, you have to do something called delete x dot b. And this is just what you have to run. And it evaluates to true. I guess if it doesn't have a b, it will probably evaluate to false. Nope, it doesn't care. It just always gives you back a true. Wonderful. It may be, maybe it's if, nope, that's an error. So I guess the thing just always evaluates the true for some reason. But now X doesn't have the B anymore. We've deleted it. It's gone. And that's what the delete keyword is for. So this kind of demonstrates it. We have pop is a thing that you use on arrays. So if we do x.pop, it's going to say pop is not a function because X is an object, not an array. Yeah. But if we do node scratch and run this, you can see how the first time, I mean, this is the whole thing I just did basically. If you assign this thing to undefined, it still exists in the object, but it has the value undefined. If you delete that property, it's truly gone from that object. So we'll see first X undefined, and then finally, yes, our empty object X is really gone. What if the object is in the array? Mel, do you mean like if we said like an array that contains an object like this? So yeah, so you could say X, so that has three things, two numbers and an object in as its third array item. You could say x.pop, it will give you back the object, and X now only has one or two. So you can pop an object out of an array. You can pop anything out of an array. So X in this case is an array. And maybe it would be better to call it R or something like plural to give you a clue that it's an array. You can call pop on an array. But if X is now an object, it no longer has a pop method. So only arrays, you can call pop on any array. If basically if the outer thing is a square brackets, if it's an array, you can call pop on it. And it doesn't matter whether what you're popping is an object or an array or whatever. But you can't call pop on anything but an array. Let's see. X dot, is there an equivalent to pop for an object? Why don't we just search this? Pop for an object. Pop from object. JavaScript pop from object. Sounds good. I wrote the following code to pop a property from an object as if it were an array. So what they do is wrong way to pop for key in profiles. Profiles key equals 0. Delete what? Just in case delete break. This is, I don't know about this. This is for key in, let's see. For key in object. We're going to talk about this a little bit. There's a newer version of this you want to do but that's a bit later in the slides. Aha. Here's a nice way to do popping basically from an object. You can use our three dots, our spread operator. And so let's say, let's try this. Let original equals A1, B2, C, an empty array. Why not? So this is an object with three keys. I could effectively pop from this by saying original equals, or wait, I can say, C original, wait a minute. What am I doing? See, let's try this. It doesn't like that. Oh, wait, const or oh, geez. Okay. So you can't pop and then end up with it in the same, because you need to declare a new thing like this. So you'd say, or let's check original. Anyway, this is getting a little silly. Like, this is an interesting question, but I clearly don't know how to do this. We could do const c others equals original. And that won't modify the original. It'll still have all three. But our C will be C, the thing we wanted to grab out of it. And our others will be everything else. So that's one way to kind of end up doing like a pop. You can't assign it back to the same. You can't change mutate original like this, I think. But yeah, you could do the similar kind of thing where you grab one item and you end up with a new variable which has the rest of the items, and you do it with this and the destructuring thing that we talked about. So yeah, that's kind of a way to sort of pop from an object. Yep, no problem. Okay. How do I remove a key from a JavaScript object? Yeah, so it really, the more straightforward way, Lodash. This is like a helper library, which gives you all kinds of fancy things to do to manipulate objects. That's pretty cool. But we could also do probably, we could also probably do original like this. First, we do const c equals original dot c. Const other c equals original dot c. And then the second line, we would do delete original dot c. So first we assign it to a new variable and then we delete it. And that's the same kind of thing as this, but this is like a fancy way to do it all in one line. We end up with our array. And original now has actually been mutated because we did this delete keyword thing. That's the only way to really remove the property entirely from that object, is with that delete from the original object.
Excuse me, Gus.
Yes.
I'm sorry, this is Latonia. Did you explain why it returned a Boolean? Why it said true when you deleted it?
So the expression delete original dot b, for some reason that expression evaluates to true. I have no idea why, but it is an expression and it apparently evaluates to true. We could look for that. Why does a delete expression evaluate to true? Yeah, nobody is. Yeah, let's see. Delete operator. Delete this expression. Okay, this is the thing to delete expression, and that should evaluate to a property. Yeah, okay, property reference, sure. Return value. So I don't know why it's called a return value, because delete is not like a function. True for all cases except when the property is an own non-configurable property. I have no idea what either of those mean, in which case false is returned in non-strict mode. All right, there's your answer. Hopefully that clears it up for you. All right, we could click on these. Own property. Oh yeah, okay. So yeah, so own property actually is something that related to what we talked about yesterday. It's things that the property or that the object itself was assigned. The object itself has that property. It did not inherit that property with one of those weird prototype things. So if it's like, if it got the property by being a new class, blah, 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 whatever, and it inherited the property, it wouldn't be considered an own property. I don't know why they call it that, but everything that the object has itself is an own property. And then I guess, let's see, if it's an own non-configurable property, non-configurable, this must be a new thing. Oh, freeze. Yep. So there's like these methods. I didn't even put them in the slides because honestly, I've never seen these in the wild and I don't know if they're very useful, but there's stuff that you can call on objects called define property, which is like a really fancy way of just making a special property that has all kinds of like writable, you can make read-only property somehow that you can't change and all kinds of this other stuff. I mean, you might get into this for some reason or another, but I've never really seen this in the wild. Freezes an object. And a lot of this must be pretty new. Let's see. Internet Explorer 9, no kidding. So freeze, okay. Frozen object can no longer be changed. Freezing an object prevents new properties from being added to it, existing properties from being removed. But if any of its properties are objects, then those objects have to be frozen too, or else they are references, so you can change them. So yeah, I think we could try this, but I've never really seen this. So yeah. Yeah, so I guess what it's saying is that these an own non-configurable property can't be deleted, and it would return false if so, unless it's in strict mode, I guess. I don't know. Okay. Yeah, let's look at some other things that we can do with objects. This is kind of like, you know, I didn't put in here object freeze and object define property because they're just kind of, if you really care about all the different things an object can do, again, like what I said yesterday is, you know, there are books that are going to go into great detail about objects. We're not going to have time in the class to exhaustively go over every method, but you know, you can find probably chapters about objects and in like new books. You want to make sure to have like a newer book because it'll have the newer whatever. But to get the latest understanding of like what modern browsers can do, you can always do this MDN and then whatever. So MDN object is going to give you just this very comprehensive thing, which is going to be full of that word salad. But it'll show you all the different methods. And we're going to talk about assign. We're going to talk about entries. Yeah, you can do the reverse. You can make an array of arrays that are key value arrays like this, and turn that into an object by using this new thing from entries. And actually, I don't know how new it is. If you click on any of these, it has an example and the description of the parameters and what the result of calling this. Yeah, Latonia, I mean, see, here, if you scroll to the bottom of any of these methods, it will show you browser compatibility. So it really depends on like whether you care about running it on some ancient browser. Like this one, Internet Explorer doesn't even support it at all. And Safari only supports it from version 12. Chrome supports it from 73. I'm probably on like 80 something. Let's see. So this is, 90. So this is it is a newer, this thing from entries is much newer. And you can see pretty much exactly by checking this and saying, well, you know, it's not going to work ever on Internet Explorer. It's probably going to work on most other things, but a Mac computer from 5 years ago might be too old. Chrome from, you know, if you haven't updated your Chrome for whatever reason, it might not work. So yeah. And it might say like partial support in some cases. It's basically like, yeah, that'll tell you for any particular thing, basically how new it is. Keys, this is much older. So this will say, this works all the way back to Internet Explorer 9, Safari 5, Chrome 5. Wow, that's a long time ago. We're on Chrome 90 right now. Okay. All right, let's look at some of these other things we can do with objects. Okay, the first one, this is just some background on a technique you can use with an object, which is very similar to the spread operator. So the older way to do this, before there was the 3 dots supported in most browsers, you would, if you had 2 objects and you wanted to combine them together so that they were all in one object, but you didn't want to have to alter this one or this one. You wanted to leave both of these intact. Or actually, you wanted to leave this one intact in the first case. You can use a function that is not on the object. So sometimes when you see, here's how you read this here's how you understand this kind of thing. See how we're not calling obj1.assign. That doesn't exist. I don't know why VS Code thinks it does, but if I try to run it, I'm pretty darn sure it doesn't exist. Yeah. Assign is not a function. So we don't have this function right on the object itself. We have it on our class or our prototype or our, what do you call this? I mean, this is like a special capital O object, which exists everywhere in JavaScript. And this is like a class method on this class. So you have to call object.assign rather than obj1.assign. And the way you tell those apart, if you're looking at the documentation, this will make a little more sense than it did yesterday, because object.create, you have to call all of these things on this actual word object with a capital O, which is like a reserve. This thing is just exists in JavaScript. And then if you look at instance methods down here. So here up at the top, it's called, they're called static methods, not class methods. But sometimes in other languages, this kind of thing will be called class methods. These are when it's object.freeze, you have to literally type this into your code. Instance methods are the ones that are the thing.prototype.whatever. So like object.prototype.toString, that is on obj1.toString. That's fine. So anything that's object.prototype.thething is going to also be available on the objects that you create like this, because they do that prototypal inheritance thing, and they inherit these methods. And this still exists exactly as you see it in the, this still exists exactly as you see it in the documentation. Capital O object.prototype.toString, and you can pass it obj1. And we'll log both of these really quick, just to show you that they should have the same result. Yeah, and it's just object. Okay, well, that's not super helpful. But the point is that anytime you see in here, if you're looking at object or array and you're looking at these methods, the ones that have no prototype in the middle, you have to call like this with literally capital O object dot whatever. The ones that are object dot prototype dot whatever, those are going to be inherited by every object because of this whole prototypal inheritance. So that's why they say prototype. And this implies that you can call them on anything that is an object. So this. Now, this here, the assign is, again, not on the prototype. It's not on, you don't do object one dot assign directly. You have to do capital object dot assign. And the first argument is the object you want to copy into. And every object after that is another object you want to copy all the properties of this one into this one, and then this one on top of that, and then anything after it. So as many as you want, you copy them all into the first argument to this object.assign. And it will actually change object one. So if we run this once, and then we just log object one, it's going to have everything from object two copied over it. So B4 will overwrite B2, and this new C5 will be added to the end of it. Whoops. A1, B4, C5. So everything from here, all the properties in here will be copied onto here. Now, instead, you might say, well, I don't want to alter either of those objects. I just want to combine their properties, and object two will win. So B has to, I mean, it can't have two things called B. So one of them has to win. And it's going to be the last one in the series you give this. But the technique you might see a lot in the real world, if you're looking at slightly older code, is object.assign. The first argument is a brand new empty object, just like this. And this is a way to say, don't change either one of these, but copy all of their things into a new object. So we get a new combined object. We'll call it object 3. And hey, we'll just throw another literal object at the end here and give it a D that isn't in any of these, but this one will have 4 properties once it's all copied over. The B will still win, the C will be there, and the D will be there, but it won't break object 1 or 2. It won't change object 1 or 2. So here's the new one, and object 1 and 2 are still unchanged. This is like a slightly older way of sort of extending. I think there's also a method called extend, and I sort of forget what that one is. Let's see. No, there isn't. Anyway, this is sort of an older method of combining the properties of more than one object, or taking the properties out of one object and putting them into a new one, into a different one, overwriting one, things like that. These days, with the more modern JavaScript, this is usually achieved with the 3 dots. So instead of object.assign, empty object like that, instead of this, which is like empty object, copy these ones in, copy these ones in, and then copy one more literal thing just for fun. Instead of having to do it that way, we can do it in a way that has less stuff to look at, basically, by saying, I want a brand new object, so I'll do the object literal brackets are here. I want to spread all the properties from object 1 into it. And then I want to spread all the properties from object 2. And it works in the same way as this. So anything that is the same between these, the last one will overwrite it. So object 2's B will overwrite object 1's B. And then I don't even need to wrap this in a brand new object. I can just add more properties at the end of this that aren't spread. These are not coming from anywhere, any other object. So I don't have to spread that object out into this one. So this is like the more modern way. This is more modern way of doing that. And just like this, where the first argument is a brand new object, this, we're creating a brand new object. We're not altering this or this. So those will be unchanged. Okay, so assign, you might see it in older code or in code that runs in older browsers. But it's largely been sort of made obsolete by this 3-dot operator. Okay. So here's another method. It's been sort of not entirely replaced itself, because this converts an object. This takes an object.keys. Oh, sorry, Carolyn. Why are curly braces used instead of square brackets? Arrays were contained within angle bracket. Do you mean greater than and less than? Arrays are square brackets.
I meant to say square brackets again, but that example we were just looking at the top, you had, a colon space 1 comma da da, and the second one for object 2. Maybe that's not an array. It's in curly braces, and I thought that was an array, so it should be in square brackets.
This is not an array. This is an object. Curly brace
Oh.
means object.
So the whole thing in the curly brace is an object.
Yeah. Whenever it's an expression that's wrapped in curly braces. So the tricky part about that is that if you do for and then there's curly braces, that's not an object. That's a for loop. So curly braces in different contexts can mean different things. But when it's like this on the right-hand side of an equals,
Yeah.
and it just goes right to curly brace, that's an object.
Yeah, I'm talking at the top. Const object 1, const object 2 equals curly brace A colon 1, B colon 2, B colon 4, C colon 5. What is that then?
These are both objects. Curly brace
Okay.
means object. Curly brace, an expression that is basically just wrapped in curly braces, or something on the right-hand side of an equal that's just curly braces, that's an object.
Oh, look down there. Okay. Thank you.
These are all, everything in here is an object. There's no arrays in this example at all. Now, let's say I have an object like this first object, A and B. I want an array that just has the string A and the string B. For whatever reason, I want to be able to do a map of that, or I want to be able to do something along those lines. There's another method, capital O object dot keys. This static method. It's not something you run on the object instance itself. It's something that you run on that capital O object. So if we log the object.keys, the result of running object.keys, and we pass it our, I'm going to call this my object, just so it's not confusing which object I mean. My object is the instance, this thing that we, yeah, by the way, this is what I never really defined this in programming. When you have something assigned to a variable, that's an instance of whatever. When you have an object assigned to a variable, it is an instance of of an object. It's instance just means it's been assigned to a variable. It's not the capital O object. It's the opposite of class. So if object is like the pattern, the factory, if the class is like the pattern, the factory, in this case, it's the capital O object, then the instance is the thing that is produced by that class, the thing that follows that pattern. And in this case, whenever you do a curly brace, object literal like that, that is an object instance. So that's what I mean by saying, the instance doesn't have a dot keys. There's no my object dot keys. There's only the static method on the, whatever this is called. We'll call it a class, whatever. JavaScript likes to pretend it has classes. We'll call them classes. Object.keys. So this capital O object has the keys method. You can see it right on the documentation. You pass this your object instance, or your variable that holds your object that you've defined up here. And this is going to return an array. So this will take an object as an argument, return an array. And that array will have just the keys in the object in a list. So A, and then B, and then C. And these are all going to be strings because that's what they really are. The syntax lets us omit the quotes, but they might as well be written like this. That is actually also valid JavaScript. So your strings, your keys can be strings just as easily. And in fact, they basically are. Sometimes you might need, if you want, you can put the keys of an object as like A key, B key, C key. And then you could actually access these with my object A key. And that works. This will access this key, even though it has a space in it. It's a string, it'll work fine. And the value of this whole thing will be the value of this key. If you try to do my object dot a key, that's not going to work. You would need to do this way if for whatever reason you have keys that have spaces in them. I really don't recommend it in general because you're going to have to do this everywhere then. It's never going to work if you try to do dot a key because JavaScript parser is going to be like, what the heck's going on here? I can't figure out what this means. Anyway, let's go back to the way it was. The point is that once you list the keys in your object, this is going to turn into an array of strings. Whoops. It should be different. That would be nice. Yeah, this is going to return an array of strings, and the strings will be A, B, and C. And then I could actually iterate for let I equals 0, I less than, let's see. What's my keys equals that less than my keys dot length plus plus console dot log my object my keys I. So we go through our new array. We loop through our new array. We take the key that's A, B, or C. We use that as a way to index to our original object. And this is just a very exhaustive way of printing each value in my object on a separate line. So we have some string, 42, and false, because these are the values. Now that would be a very silly way to do that. Like if that's all you're doing is just getting the value for each key in a row, there's another method called object.values. You can just do that. And that returns an array of the values, the things on this side of the colon. Now these aren't all strings because, that's a string, that's a number, that's a Boolean. That's okay. I don't like indentation there. So we have string, number, Boolean. So object.values is a function on this capital O object thing, and you pass it your object and you get returned a array of the values. There's one more, object.entries, that's very similar. And this gives you both. But in the format, instead of as an object with this kind of keys and values, this gives you back an array of arrays. And it's a top level array that has one item for each key value pair. And each item in that array is an array that's too long, where the first item is this and the second item is this. So you'll see a nested array with the keys and the values. A something, B 42. It matches the structure of this. And then let's just copy this right out of here. If we said const blah equals that, I could do console, whoops, on console.log object.from. No, isn't there a from keys we just saw? Object.from entries. There it is. And our VS Code doesn't recognize that. It must be too new, but maybe it'll work. Let's see. Object from entries, blah. So we'll just dump this back and we should get our original object back, or not the same reference to our original object, but a new object that has the same keys and values as our original object. Yep, so that works. So we get the entries, which is this array of arrays that each have two items in them, key and value. And then if we dump that into from entries, we turn it back into an object. So this is like how you could convert an object into an array. You could then pop a key off of it. So if you were like, well, gee, I want to pop something, I want to pop the last thing off of my object. You could say console, you could, let's see, how do we do this? We could say const object entries equals that. Now here we have an array of arrays, so we could say object entries dot pop, or might as well log it. And then turn it back into an object. So object with a capital from entries, object entries, which should now have one less item. The thing is, I don't know if there is really a guaranteed order that it's going to turn this stuff into an array. So this might be a really terrible idea, because you never know what's going to be at the end for sure, I think. If you're not confident that it's always going to be B or the last thing, and I guess it happens to be in this case, and maybe there's some guarantee about that, but you get what I'm saying? Like, turning it into array doesn't necessarily guarantee that the order of the keys is all the same exact thing that you might expect. The keys are just strings that map to things. It's not a sequential order necessarily. I mean, we could say BA, and let's see what happens there. We should pop off A42 this time if it does, if it does what we expect. Maybe it will. Yes, it does. Okay, so, well, I still wouldn't trust it. But anyway, that's one way you could try to pop off an object, something that lasts something from an object, and then turn it back into an object. Very convoluted way. I don't know why you'd ever do this, but that's just an interesting way. Now that we turn it into an array of entries, we can pop it, and then we turn it back into an object, which is probably the wrong way to do this. I wouldn't recommend that. Okay. Okay, so this whole time, this whole time I've been writing those for loops with let I equals 0, I is less than blah, 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 blah. That's been the harder way to do a lot of this in modern JavaScript. And I'm sorry for not telling you about this sooner, but there is an easier way to iterate over both the keys and values in an object and the entries in an array. And this is only if you need the items in the array, not their index position. So if you needed to know that this was index 0 and this was index 1 and this was index 2, you'd still want to iterate like the other way. And I'll write out the other way right below it. But if you just want to grab the items this in order in a for loop and do something with them, all you really need to do is use this form. And this is like you define your thing. This could also be called I, but it wouldn't make sense as I because it's no longer an index. It's now the actual element in that array. But all you need to do is, define some variable to hold each element inside your for loop, and you use the keyword of, and you put your array at the end. So const element of array. This will run once for every element in this array or of this array. And you'll get the element as a reference called element right here. So this is going to make it much nicer than doing it the other way, the older way, which is for let I equal 0, I is less than our length, I plus plus, and then in here, doing console.log element, our index of I. These are equivalent. And we'll see it print each element twice. ABC, ABC. The first way, much easier to understand, harder to screw up. You don't need to do all this stuff with the semicolons. And yeah, it's convoluted. Carolyn, I don't know. COBOL is perhaps less complicated than JavaScript is at this point. JavaScript is a very complicated language, but I'll bet it's not as nice to work with because JavaScript in practice, it's actually very nice to work with. I avoid using a whole lot of this. Like I never really write a for loop like this anymore. We have to teach it because that's the traditional way. It bears similarities to other languages. I actually don't use this very much either. I normally do this, r.for each. I like this way. Element. Because this one, you can also get the index right away if you need it. Element and its index. But yeah, I'll paste this stuff in to pasted code just because this is a nice little 3 ways to iterate through an array. I like the last one, so I pretty much never write these ones. But if you prefer the for style, if you don't want to do this function pass to function thing, you can use this way. I think you can't get the index. I'm not actually sure if there's any way to get the index like this. But yeah, now we'll see it 3 times. ABC, ABC, ABC. Yeah. Okay, Mel. Iterate and only pull selected items. What is your method of selecting? How are you gonna know whether an item should be selected or not? Because I mean, the answer is yes, but I need to know what's selecting. How do you know what is selecting? Like maybe checking whether it's B. Or you mean filtering the array? Do you mean like taking this array, checking each item and returning a smaller array? Okay, filtering. Yeah, well, I should have added that to the slides, I bet, because there is a newer thing. Yeah, array filter. Here it is, array prototype filter. It is built into JavaScript now. So let's say we have an array of numbers. Man, this should have been in the slides. Thanks for reminding me to tell you about filter. There's all kinds of things you can do with arrays these days that weren't built into JavaScript before. This has been possible since Internet Explorer 9. So if we had an array with 1, 2, 3, 4, 5, 2, 9, 3, 4. Yeah. Yeah, but Carolyn, you can't do anything with basic. I mean, you couldn't make a website, web app with basic. Come on. You're gonna make such a cool capstone with this stuff. I would like to see anyone try to write something that does the same thing in basic. It's doable. It would just be just as hard, I think. And it wouldn't run anywhere. It wouldn't run in a web browser. Anyway, actually, sorry, getting a little sidetracked here. Basic in web browser. Maybe QBasic. Running QBasic in your browser. Yes. So you can run all of QBasic. Yay. Look at this. It's DOS. One. We're playing a DOS game in the browser. Yes. Monochrome. Yeah. Initializing playing field. Wow, so it's the snake game. And it's apparently programmed in QBasic, and you can look at the code right here, basic code. So if you want to write that little snake game in basic, it looks like this. It's pretty long. Anyway, that's fun. It's the future. You can run basic in the browser. Okay, sorry, back to the actual scheduled programming. Let's say, yeah, we want to turn this, we want to take this array and filter out everything that's lower than 5. So it's pretty easy. Const filtered equals filter x greater than 5 or greater than or equal to 5. So that does what you want, Mel. 5 and 9 are the only ones greater than or equal to 5. Greater than or equal to 4. We could do that. We could do the even numbers. Mod 2 equals 0. Only the evens. Or the odds, not equal to 0. And so forth. So yeah, filter is a really powerful method. And this, again, this is an arrow function. So this works the same if I said function that takes x and it returns x mod 2 is not equal to 0. Those two would work exactly the same. But when you're doing like a really little quick check like that, where it's a very simple expression, it's much quicker to just say like this. Carolyn, you mean like x mod 2 is not equal to 0, like that not here?
No, but that made me think of it. I'm not tracking. I'm sorry. In this case, that's different. All right.
Okay. Well, so that is like, you notice how I do not equals equals, just like you do equals equals equals. And that's for the same reason that if you just do not and a single equals, JavaScript will do all its weird converting between types and making true equal to one and all that kind of stuff. That you know, you don't necessarily want to happen. It's usually easier to prefer, it's better to prefer the stricter definition of not equals or equals equal, like three
Okay.
equals or a not and two equals. There should always be 3 characters total, unless you really know why you want the other way.
If you were doing any greater thans or less thans or anything, would you use the exclamation point as a not?
There's no combination of not greater than, or
Okay.
there is, so you could do greater, so the way you could do this is x greater than 4. Okay, you could wrap this whole thing in parentheses, and this is going to evaluate to a true or false altogether. And if you put a not in front of that, it'll flip it from true to false and from false to true. So this would effectively be the same thing as saying, so I'll prove this. 1, 2, 3, 2, 3, 4. This would be the same thing as saying x is less than or equal to 4. Because when you do the not, if the original didn't have the less than or equal, or if the original wasn't greater than or equal, the flipped one is less than or equal, because equal is not covered in the other case. So love this.
I'm gonna take your word for it, Gus.
Yeah. Doesn't everyone love how easy that is to look at? We have x, boop, x, boop, and then a 4.
I feel like I'm on heavy tranquilizers.
We could put another x in there, and that would be valid. And that's not going to filter anything, by the way, because x is always at least equal to x. So yeah, it's the whole array.
Hey.
This is insane. There's no
Yeah.
reason you ever do this.
That's why it hurts my brain. Okay.
Yeah, so this is partly why I'm trying to pitch all of the free code camp exercises and just putting regular time into this, because even this makes my head spin. This is like, what the heck is this? But for a lot of other stuff, if I'm looking here, my eyes are trained to not only see the shape of the stuff, but the colors, and it just jumps out at me, and it's obvious what this is doing right away to me. And that takes a long time of just, it's not that I know what an arrow function is and you don't. I mean, you've all learned that this is a function. This is the same as a function that takes the parameter x and blah, blah, blah. It's just that my eyes are so trained by doing this over and over so long that I look at this and within a second or two, I'm like, oh, it's a lambda, or it's an arrow function that checks whether x is greater than 4. I can just read it like that as soon as I see it. And that only comes if you practice looking at code and typing code and looking at code and typing code for long enough. In my case, 15 years or so. So, don't expect this to not be confusing when you look at it. It's a little confusing to me because this thing and this thing are very similar. I don't like that. But I'm very used to it. And part of the exercises, the point of the exercises, a lot of it is to get used to it. That's part of the skill. It's somewhat different than learning to sort of solve the puzzles and think like how to break down a problem into programming sort of like concepts and in a way translate it into a way that the computer can understand. For that part of it, definitely reach out for help and say, hey, I'd like someone to do some of these problems with me, or I'm stuck right here and I don't know what to do next. Definitely reach out for that. But you're going to need to do both. You're going to need to kind of like get get the understanding of how to solve the puzzles. Whether or not you're getting help or not, that doesn't really matter. But the part about the reading, recognizing the code, getting good at typing it, getting good at just not making typos and things like that, that's something there's nobody else can help you with that. That just is going to take time, and you have to do that on your own largely. So yeah, if you get stuck, don't, do whatever you need to do so that you can keep learning and keep training. And that means reach out for help. That means don't say I'm supposed to solve this on my own. You're really not. You're supposed to learn how to solve it, but you really are supposed to learn how to read code and learn how to type on your own. You're going to have to. So that's the part that takes the time. They're somewhat independent, but you need to be working on both, and you can get help with the one. The other one, I mean, there's really nothing anybody can do to make you see this in the way that I see it. You just have to do it enough, and then it's inevitable. You will recognize you'll understand the code quickly because you'll be so used to it. Obviously, if you go get a job that's in a different language, and even like when I work on Python servers or in databases or something for a couple months, the first week I come back to JavaScript and I'm trying to do like a React program, I look at this stuff and I'm like, oh man, I don't remember any of this. Like this all looks like squiggles again for a little while. And I'm always typing the wrong thing instead of console.log. I think I did this in the class. I'll be typing print, which is like, that's not even a thing. There's no print, So yeah, it's the practice part is just something that each one of you really does need to do on your own. But the getting stuck part is not something you have to sort of push your way through on your own. The getting stuck part, if it's interfering with the practice, get help, ask for help, get yourself unstuck, however you need to, because you can't really only do one or the other. You need to be doing both, working on the puzzles, getting help with the puzzles, and working on your, how do you describe it? Like your literacy, or it's sort of like learning to read. It's like your comfort with the characters, the syntax, and the rapidness that your brain will kind of connect seeing all this jumbled stuff with the concept. And by the way, we haven't even gotten to regular expressions yet, which is going to be the biggest bunch of nonsense that any of you will have seen for a long time. And you probably won't use it. You probably are just going to be getting help with it for like years and years, because it's code that looks like this. I'll give you a little preview here. We have, let's say we have const my string equals the quick brown fox. Now I want to, I think you can do a lazy dog. I want to change, I want to say, well, it's not a brown fox, it's a gray fox. So how would you do that? Replace, so you can do my string dot replace gray brown with gray. That will work. And now it says the quick gray fox. But what if this could be anything, blah fox, and I wanted to find anywhere where it says quick something fox and it replaces whatever this word is with gray. How am I going to do that? It still says quick. Now I could say blah, but let's say I'm writing a function where I'm like, well, always replace the adjective before fox. the way you do that is with a regular expression, which is this kind of thing. It slashes like a comment, but there is something in between it. It is like this. I need to think about this for a second. It will be word characters, more than one, and then a space character, and then the word fox. And I'll replace it with gray fox. And now anything I put in here will be replaced with gray. Unless I put two words in here, in which case it only replaces the second one. So what if we wanted to replace everything between quick and fox always? Well, I could do like this, quick, any number of characters in the middle, and replace that with quick gray fox. So anything you put in between quick and fox is going to be removed. That's regular expressions. They're pretty cool, but learning what all of these little dots and blah and blah and blah and blah is like one of those things that everybody who's a junior programmer, even people who are getting paid money for like years and years, still are like, man, I hate those things. I can't remember what any of it means. How did Karen, did you already read something about regular expressions, Karen and Dominique? Did you know, how did you know that? You already know about this stuff? These are programmer secrets. How'd you find out? Anyway.
Free code camp.
Okay.
Actually, I got stuck on that.
Okay, well, look, if you're getting stuck on regular expressions, that you're doing pretty well. So yeah, everybody gets stuck on regular expressions. Most people are stuck on them for years, and that's really cool. So you're definitely like ahead of the class in some ways, in some subjects. And those, I am not going to badmouth regular expressions. They are very useful. I mean, you saw like a kind of a contrived example, but anytime you want to recognize some pattern in text and do something as a programmer, they're like going to be the tool you reach for. Of course, they are also very tricky to get right. Let's see. Now you have two problems. Yep. This is a common, somebody's famous quote says, some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have two problems. That's a nice, it's a programmer joke. Anyway, I didn't want to, we're not going to really get super into them in this class because they could be a whole week or a whole module on their own. There's tons of details. The cool thing about regular expressions is all of the basics are pretty much the same in almost every language you're going to see. In Python, in C#, in Java, in C++, maybe. Actually, I have no idea. Regular expressions are like a standard that kind of crosses over many different programming languages. So you learn them once in JavaScript, and when you find them again, if you're working on, a Python server or something later on, you're not going to have trouble reading them or using them once you're at that point. So that's nice. There's something of a standard among all programming languages, or most programming languages in use today, in wide use. Okay, sorry, back to the stuff. We can iterate over an array with this of. We should take a break and then do the last bit. We're not going to have much of an example today, but this was just full of this day is just full of like little examples. You can also iterate over the keys and values if you want in an object with the same pattern, this of operator. And the way we're doing it is by, remember this dot entries. This turns our object into an array of arrays. So this turns our object into an array that has one item for each key value pair. Each item is another array, which has the first thing is the key and the second thing is the value. And we can use this destructuring operator. This is very similar to, remember, the curly brace destructuring, object destructuring operator, but we can use it for arrays too. And we can say, okay, turn this into an array of arrays, iterate through that array, and assign each thing into a destructured thing here, which immediately grabs us key and value. And then inside your for loop, all you have to do is use those key and value. So I'll show you this real quick, and then we'll go to a break. So we're logging key and value each time, A, sum string, B, and 42. So we have access to all of those, and we're looping over everything in our object. Now, object.entries, yeah, I think this is the right way to do it. There are some tricky things about prototype, properties that are on the prototype. I think the of is what you definitely want to remember to use of for objects, because I think if you do in, that's another way I didn't even show you about objects and arrays. The problem with in is it's basically useless because, okay, well, it doesn't even work for, wait a minute. It doesn't work for arrays, it works for objects. And it doesn't, I think it pulls in a bunch of other junk too from the prototype and from this and that. Oh, maybe not. Huh. Why don't you use in? Anyway, I never use either of them. I use the functional way, dot for each. Object for in. All enumerable properties of an object that are keyed by strings, ignoring ones keyed by symbols. We haven't even talked about symbol. That's another type that you can look up if you care about. It's rarely used in, but it's like a string, but it's like it's a globally unique string. So every time you have a symbol, it's totally not equals to any other symbol anywhere in the program. And that is, yeah. Karen, you're talking about the free code camp examples. Yeah, it's a really nice pattern for like learning things because they really do a good job of explaining each thing you're trying. And then you try it immediately, which is pretty cool. It's like watching what I'm doing, but yeah, you can sort of control your own pace. There's plenty more examples than we have time for in class. And yeah, it's really great. It's a great resource. So yeah.
Exactly. It gives it to you in bite-sized pieces.
Yeah. Oh, I wanted to show one other thing. If you tried this execute program, this is a newer thing, and I know I recommended this, but let's see what happened. Right. Wait a minute. Get started. You already logged in. Wait a minute. Okay. Arrays. Didn't I? Okay, crap. Ah, man. If you did this one, I think Shai, you reached out about this. If you start the arrays thing, and this is true of, I'll show you this in free code camp too, and then we'll go to a break. But let me just do the first couple. so Shar got to this first quiz, and this function, it says, write a function is empty that returns true if the array is empty. Okay, well, let's say if r dot length equals 0, return true. That does exactly what it's asked to do. But when you run it, it says no. And this is true of both this interactive thing and free code camp. So whichever one you prefer. Sometimes the lessons aren't perfect. They're not always unambiguous, because what this really should have said is returns true if the array is empty or false otherwise. And there's really nothing explicitly telling you that that's what you're supposed to do. You need else return false, like that. Or you could just return this, which will be true or false in the right cases. So you need to return false. The way that you can tell what exactly the difference between your answer and what either one of this thing or free code camp, and I'll show that example right after this, is that you can find the list of test cases in the case of this execute program course. They're listed right above, and it says 4 tests, 3 failures, and it tells you exactly what it's trying to run your function with and what it's expecting to get from your function and what you're doing instead. So because we're not returning false or returning anything in the other case, or weren't in the past, it was getting undefined and it expected to actually get false. So you can kind of see sometimes like what you're really supposed to be doing if it's unclear, just by looking at what the tests are expecting to see when it calls, for example, this. So this way will now work. And that's for that one. But let me just do the free code camp one really quick too. This thing, let's see. Ooh, let's basic data structures. Let's try index of. If you scroll all the way down on the left, it will tell you each of these little beakers here, it's the same kind of thing. It's a test case, and it will tell you all of the things that you should, that your function should do. And then this side down here at the bottom, it will show you all of the things that you still need to, all of the tests you're still not passing. So this tells you all of the tests. And then down here, this will, I think, tell you which ones you're not passing. So the quick check function should return a Boolean. And I can tell what it's asking just by reading the tests. If you really want to, you don't even have to read what it asks for. You can just say, return true, onions, squash, shallots, onions. So it's asking, so the first thing is an array, and the second thing is the thing to check whether it's in the first thing, right? Yeah, okay. So it's gonna be array and element. So we'll say return in our index of element greater than -1. Is that right? It works. So let's see, return our index of mushrooms or squash. So this will pass some of the tests. I don't know why you do this, but this one, we can see the tests that it did not succeed with, only those are printed at the bottom here. And if you scroll down to here, you'll see it passed this one, passed this one, passed this one, and these are the 2 that it printed out, the X and the X. So I'm only failing 2 tests, which is a little surprising because this is clearly wrong, but this should give you a little bit more help to like understand how close you are to getting the right answer. Sometimes it does mean you just have to you have to restart, and you're just in the wrong approach, and it's never going to pass all the tests, and you have to start over or ask for help. That's still going to happen. But this might help you sort of figure out the direction you might need to go in a little better, is just by keeping an eye on all the tests that are passing and failing for both of these tutorials. Anyway, that, by the way, that's the answer. Array index of the element, it's got to be greater than -1 because 0 is a valid array index. Anything positive is a valid array index. If it's not in the array, it's going to return -1. So this will work too, I think. Not equal -1. Yay. Okay. All right. Break time. Let's come back at 7:35. And we got a couple more things. We're not going to do a ton of examples, but we're going to talk about errors and try catch. And that's it for today, I think. Nothing super confusing like this, thankfully. So see you at 7:35. Sorry for the short breaks. If you need to 7:40, let's do 7:40. We don't need to spend a ton of time. So see you at 7:40. Okay. All right. Raise. Okay, so we have, yeah, really just errors and try catching and stuff. Like that's not super confusing stuff, which is good. I'll be right back. Any questions? Just holler or type or breathing exercise. Man, I've really been slacking on the breathing exercise. I said I was going to do breaks during class. Oh, Jazz, good call. Let's see. All right. I think I'm going to start getting started. Let's get back to our slides. 7:40. Yeah, we're not going to rush through stuff. If we have some time, maybe we'll try to update the card trick. Has anybody like been trying to pull that apart? Is it like, did most of that kind of, could you see how it sort of could work? Or like, I know that's that example yesterday was like, that's a whole ton of, stuff that's pretty tricky to understand. But, I wonder if we should spend any more time on that. Just any of the parts that are really tricky, like the mod. I think maybe we should do that, like an exercise of how to think of the mod operator while dealing the cards, and just do that a little bit, maybe tomorrow if we got time. But yeah, if we've got a little time today, we'll add one thing to shuffle each row of the cards so that they show up in like a random order every time they go to the screen. And so it sort of fools the person into not seeing like, oh, it's always the one in the middle, and then figuring it out. So we can, if we got time for that. First, though, we need to talk about errors in JavaScript. Errors are the capital word error. And often this is, this will happen, in React code. It will look like that that other error that I showed that's in the browser, where it's like red text on white browser window, and it says error something not defined. Though they might show up in the browser, but in our node context, they can still show up, and they print out just this big dump of lines, like this line and this character at this place, and then another line at this character at this place, and then another line. And they just look like a big pile of text often. And let's demonstrate that. So somewhere, it could be your code doing this. Sometimes you do want to throw errors rather than continue your program. Or it could be code that you're using, code that you're calling, React code, something like that. And it will do something like this. It'll throw a new, there's our friend, the new keyword, and then capital E error. This is a special word, just like capital object in JavaScript. And you pass the constructor or whatever this is of the capital error thing, a string message, if you like, which will become the message of that error. The error that is thrown will actually have a property message. We can't see that error that's thrown, though, because our program is just going to stop running. If we run this program, it's just going to throw this error, say, uh-oh, and then just stop where it is and quit. So I'll paste all of this. So we've defined one function here. I don't like the indentation. We've defined one function here called this throws an error. It doesn't do anything other than throw a new error. Let's say we've made another function. This is just fictional, but imagine this is something that tries to do something and fails and ends up throwing an error. Let's say we have another function called my function, and it does whatever it needs to, but at some point it calls the thing that throws the error. And this one obviously fails. Obviously right now, that's all it does. That's all it can do. So this function inside here is going to throw this error. That error is going to bubble up. It will just keep going out of this function and then all the way out into the global context. And if nothing is there to what's called catch that error and handle it, do something with it, that's it. Your program's done. It's going to just crash, basically. So if we run it, maybe save it first. We run this. We're going to see a whole bunch of stuff. So I tried to run it right here. And then it prints a path to my file. Careers and code, blah, 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 scratch JS2, line 2. That's right here. That's where our error was thrown. Throw new error. It gives us the exact line that threw the error. It says error : oh no, that's the message we gave it. So this is the actual thing. And then you see all this stuff. And the way that you read, this is what's called a stack trace. So the first thing about this lesson that you're going to want to start to try to understand and try to get used to. This is another kind of thing that your eyes just will start have to learning how to read. And not everybody's very good at reading this. This is kind of like the regular expressions where some people are better at this than others, and it might take some time, but this is called a stack trace. And it's related to the execution context, if you remember from yesterday, that our functions are running in. If we look at the first line, it says first, error. Oh no, that's the message we gave it. Then it says at. This is the innermost place, the last function that was trying to run when this error happened. So the first thing it prints is the innermost, is the thing that is right next to the thing that threw the error. At, this throws an error. And it points to the same line that was printed all the way up here. So scratch JS line 2, and in fact, it even gives us a column. So column, you can find the column right here, column 9. So for some reason, it's figured out that the error happened right exactly here. I don't know why it's right before the new, but that's where it says the most immediate place of the error is. But then it continues. So this first line is the context right next to where the error threw. It's this function that we were running. It's the most innermost function that we were running. The last. So if you remember, every time a function runs, it creates a brand new execution context in which to run. And those things stack on top of each other in what's called a stack. So you run one function, that function runs another function, and the second one is stacked on top of the first. Then the inner function finishes, that's popped off the stack. That's what the word you use is pop, because it pops it off the top of this stack of execution context. So this is called a stack trace. Every at here is the next layer up from where the error happened. So you have at this throws an error, line 2, it's right here. But where did this get called from? Well, this got called down here. So the next thing is going to be at my function, line 6, right here. And then, well, where did this get called from? Okay, that's the next one. At anonymous, object.anonymous. That basically means the global, it's just the file. it doesn't know the name of this because we're just in the middle of the file. And it points to exactly where, line 9. So that's what the 9 means. And that's sort of how you read this. Now, then it continues from there. And I think this is a pretty nice feature that the terminal has helpfully made these gray, because it's basically saying, good luck understanding what the heck this is. This is not code you wrote. This is modules internal CJS loader line 955, 991, extensions JS, module.load function module load, run main, blah, 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 blah. So stack traces will often have some level of, maybe it's sometimes it's only one. It's your code called out to some library thing that broke. Only one of the things is your code, or in this case, 3 of them are. So this inner function, this function that called it, and then the file place where this first function was called. From there, it keeps going because there's more context really that guts and the internals of the JavaScript, the node engine are actually running also. And it just dumps them all the way to this one called run main module, which must be like the sort of most fundamental context where all the node programs start from. But all this stuff is not your code at all. This is like just some guts of node. So it's gray. It's not code that you touched. It's not in any of our folders that we managed. You're not going to really get much out of this. So that's how to understand this whole big dump of text. Now, okay, that's all well and good, but like we want to actually maybe prevent our program from crashing, because like the problem here is that, let's say I wanted to do more after I ran my function. I wanted to console.log. I'm still alive. And if we didn't run our function, that's fine. We would get all the way down here. But because we run our function, because it's throwing an error, and because that error is bubbling all the way up the stack here to like the top level of node guts, and then nothing is handling it, the whole program is going to crash. All we'll see is our error. So this is where I ran it. This is the last time. So that's not from our run. This is where I ran it the most recent time. Here's our error, blah, 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 nothing. So it never got to here. And that might be okay. Maybe that means something unexpected happened and you don't want to keep running your program because you got to fix something. You don't want it to just keep trying to run and maybe make things worse. Sure. But like, let's say that this might be a possibility. You might get an error and you want to be able to do something when you get an error, no matter where it happens, and prevent your program from crashing. This is where another control flow kind of construct happens. We haven't seen one of these for a little while, since like for loops and while loops. There's another construct which is called a try catch. And sometimes try finally, or all three, try, catch, and finally. What this does is allows us to contain errors and stop them from ending our program. So let's replace this outer function, the my function. Let's replace this with a version. So instead of just containing this line, so instead of my function just immediately running this throws an error, we're going to wrap that. We're going to make a new block that's called try. We're going to put our dangerous code, the thing that might throw an error, into here. We're going to close that block. And then after it, we're going to put a block called catch. And catch could be, I think you can run it just like this. And we could say, whoops. And we'll see, whoops. But our program didn't crash. We didn't get our giant stack trace thing. We just caught the error, we logged a whoops, and then we moved on as if it never happened. So we ran this, it caught our error, it continued running, it exited, and then our program is still alive, it's still running. From the example, you can give catch these parentheses and define some kind of variable here, name something. This could be called E sometimes, or whatever really, but it's usually called error or E. And inside the catch block now, we have this error, which actually is this original error object. But now this time, we can do whatever we want with it. So the error will have the message, which is going to be just this string. So let's say we want to catch our error, log the message from that error, and then keep going. And we can do all of that just by containing, basically containing this dangerous code in a try block and handling what we should do if it errors in the catch block. And when we run this, we see error message is printed, which is, oh no, but it doesn't crash our program. We're still running. We still get down to here. And yeah, so we could say, try to get something from an API. In the real world, it'll often be something like this, where you're trying to fetch some data from a server. Try to fetch something from an API or a server or whatever. And we'll say, try to get something from an API. Maybe we could say return, like in the good case, this would give us back. It would probably be asynchronous, but you're going to get into asynchronous code later. This would probably give us back some object, some like data that we downloaded from the server, from the API. If we wanted to maybe have a fallback, we could say my, fake data here. Or like, yeah, error, please gracefully we could tell the rest of our program, just pretend like we got something from the server, but it wasn't real data. It's like, not real data. ID, whoops. This is just confusing. Anyway, you can have anything happen that you want here. And sometimes this could log something. This could show a warning to user. So like we could have another thing somewhere that's like flash a warning on the screen that says, hey, in a browser, you're not going to console log in a browser, but in a browser we could say, hey, move a div up over here and show something saying, hey, something went wrong, please try again. So rather than your whole website just going kaboom and exploding, you can show something to the user that says, hey, we had a problem, and it looks much nicer. And then they can retry. And that's one case where you really would be doing this in the real world. The other pair for the try is what's called finally. So finally will not catch errors, but it will even if there's an error, it will make sure to run something here. So if you needed to be sure to, even if your program crashes, even if everything goes wrong and it crashes, you want to make sure that it does some bit of cleanup. It unsets some flag, or it tells some other program that it's done. You can put this in a finally block, and then it could still crash. It could still throw an error, but you're guaranteed to at least run the stuff in here. Now, you definitely don't want the stuff in here to crash, because then you don't have anything to catch that. But if we run it this way, see, we still get an error, and we don't get our still alive, because the program did crash at that error. But whatever's in the finally block did run before our program crashed. So the finally block is just a way to say, don't handle this error, but make sure to at least do this code when you're done, no matter what. If it succeeds, even if this just says console.log, nothing went wrong. Even if you don't get an error in here, your finally block will always run at the end. So nothing went wrong, but still done trying. And this time, because nothing crashed, we get all the way down to here. So the finally block doesn't allow you to handle errors on its own, but it allows you to make sure that something happens at the very end that you just want to make sure doesn't not run because it crashed. Let it crash, but be sure to run the thing at the end. Now, if you want both patterns, if you want to be sure to catch, handle this, run this. If it fails, run this. But either way, when it's done, definitely run this and then continue. You can use all three: try, catch, and finally. So that's pretty much it. That's how those are used to contain errors. The important thing to remember is that it's not like returning the error from the function. You don't have to catch it. You don't have to try catch here. You can wrap this in a try catch. So let's just demonstrate that. Like the error keeps bubbling up all the way until it gets into the guts of Node and then until it crashes the whole program. But you can catch it at any point. So we were catching it inside this function. We could also put a try right here and catch it any point where it runs, and it'll still be then okay. I mean, it won't necessarily be okay because something went wrong, but we can keep running our program because we've caught it before it went all the way to the top, the outer context, and crashed the whole program. Caught. So that's the important thing to understand is that errors bubble all the way up through the thing that called, the thing that causes the error, the thing that called that causes the error, the thing that called that causes the error, and as far as they need to go until either something catches them and stops them from bubbling up, or it goes all the way to the top level of the program and it ends the whole program. Okay. And so there's a couple of places where you might want to actually throw your own errors. And this practice is called using assertions. Basically, all an assertion is in this case, let's say we have a function.
Before you get into that too much, Carolyn,
Yeah.
I had a question. If your program crashes, ends, what do you do?
You run it again, usually. And I mean, you usually try fixing whatever the bug was that caused it to crash and restart it. But, if it was doing a banking transaction and it took the money out of someone else's account, or took the money out of one person's account and hasn't yet put it in the place where it was supposed to go, you got a problem, because you can't just start the program and walk away because, so there are cases where, crashing is bad and where you have to kind of provide some guarantees. In a real situation, a banking transaction would log so much data before even starting the process of moving money between accounts, so that no matter what, even if it crashed, it would be able to recover the exact state that it should continue from when it restarts again. The same thing with a database like Postgres. It will be very, very careful about writing the data that it's going to be working on, so that even if it crashes, it will be able to recover the things that it was like, hey, what was I working on? Oh, I logged it before I even tried to do it. And so I can pick up from where I left off. So like basically the short answer is you'd run it again, but yeah, the longer answer is like sometimes you have to be much more careful than that. For your capstones, don't worry about it. Just hopefully they don't crash during your presentation. It's always a stressful when you're presenting something, and you don't want it to crash then. If it crashes before, you fix it and you start it over again. Yeah. So yeah. And don't worry if it does, because it happens all the time, and it's part of the if you can explain why it crashed, sometimes that's almost as good, because it's still a fun presentation, even if and I've had that happen to me plenty of times. Here's the demo, and then kaboom, it doesn't work.
That happened in grad school. My partner and I, the project we were working on, our database, everything was wonderful. And we had it on a disk because that was the day of disk.
Yep.
And then before the professor went to play it, and it crashed.
Yep.
Which would normally mean you flunked the grad class. However, he saw us working on it. He knew. But I'm pretty sure you would have an opportunity to fix it. In any case, you definitely have an opportunity to fix it, and that's just you want to try to make your demo go really well, and sometimes it doesn't, and it's okay, because that is just part of the craft, But if you were selling banking software to somebody, you'd want to be a little more careful. Yeah, for sure. You probably won't, your first job programming probably won't be writing banking bank account management software. That's not something that they casually change at banks. They don't mess with that stuff very much, because it's very bad if it breaks, self-driving car software, the Tesla lane following. You're not going to be doing that your first year programming either, because that's very bad when that doesn't work. So yeah, that kind of thing. Basically the answer is you run it again, you fix it, and you run it again. Yeah. Okay. This is using errors to make sure that your program is not doing something you don't intend it to do. So these here are called assertions. And all it really is let's say we have a function that's called divide two numbers, x and y. And we want to actually make sure that we don't return not a number from this function. We don't want to just silently say, well, I'm going to divide true by the empty string, or like the string this by this, because JavaScript will just do that for you. And it'll say, hey, it's not a number. And then you'll return back to your user, hey, it's not a number. And then it will go everywhere in your program. You'll add it to another thing. Hey, it's still not a number. And not a numbers will show up everywhere. So maybe you want your function, when you're dividing two numbers, this function should really expect both of these to be numbers, actual real numbers. And moreover, JavaScript, if you try to divide by 0, it will happily just say that's infinity. Or if they're both 0 divided by 0, it'll say that's not a number. So you might want to also check that your denominator, because we'll do x divided by y all the way at the end here. You want to check that your denominator is not 0. If it is, that's an error. You can't divide by 0. So these two checks basically say, parse the first thing into a float. If it's already a float or a number, a decimal is fine, a whole number is fine. This is a way to check, like, basically, is it a number? You parse it again, and if it's in any way not equal to what you passed in, well, it wasn't a number to begin with. It might have been the string of the number, but that's not okay. We don't want that. That's not good enough. Or if you do the same with the y, you parse it again into a number. If it's in any way different, anyway, if it was a string before and now it's not,
then it wasn't a number. So we want to throw an error right away and say, hey, one of these is not a number. You can't do that. If the denominator is 0, hey, you can't divide by 0, rather than just continuing and having unpredictable effects. So we'll say console.log divide two numbers, 4 and 2. That should work fine. We get 2, 4, and 0. That's going to throw our error. Divide by 0, you can't do that. This is called an assertion. It's just throwing an error on purpose. Rather than continuing, you are choosing to say, hey, I'm trying to assert that all of these things are reliable. If they're not, I'm going to just throw an error because the world should know about this very quickly. I want to be notified that my program is doing something I don't expect. So an assertion is basically a way of saying, check that something you expect to be true actually is true, and otherwise throw an error. That's what an assertion is. That's it. That's really all it is. Now, TypeScript is much better at solving this particular kind of problem. If you were doing this in TypeScript, you would not even bother with the first thing. You wouldn't be like, I need to check that these are numbers. That's what TypeScript is all about. You can just say X has to be a number, Y has to be a number, and you don't have to check that everything's a number. The thing is, not only would TypeScript immediately, it would not just guarantee that like all of the code in here is going to be working on numbers. It would do that everywhere else in your program. So if you tried to do divide two numbers with true and empty string or a string, the TypeScript VS Code would immediately just say, hey, you can't even don't even bother trying to run this because this is wrong. The problem with the assertion is that even though you are interrupting and you're saying, okay, don't continue because we know this is wrong, go back and fix it before you try anything and get a surprising result that you don't expect. You still have to run your program to see that happening. The advantage that all of the extra difficulty of TypeScript would give you is that it will immediately just say, hey, don't even write that. Like, you're wasting your time. These have to be numbers. And it will be able to check that all the way throughout your program. So it's one of those safeguards that assertions are more needed, or they're more of a thing you're going to want to depend on if you're not already using like a type checker or TypeScript to check those kinds of things. Now, you still might need to write an assertion. TypeScript doesn't have a number that is not 0 type, as far as I know. TypeScript number that is not 0. Non-zero. Somebody's asked about it. Is there a type in TypeScript that reflects a non-zero number? No, not possible. Okay, so basically my point stands. TypeScript is not going to eliminate the need for assertions, testing your code, and everything like that. But there are certain things that you are going to have or want to test for if you're not using it that you can skip if you are using it. That's all. Now, and this is the last time. You're not going to hear about TypeScript again. We're not going to even try to run it. But if you go to set up your React project, I don't know if Joey is going to even mention it. You could just take the plunge and try it. I don't know if I'd recommend it. It's a trade-off. It's a lot more difficulty to learn. But when you're using it, you won't have to worry about things like this. So, yeah. Okay, last thing. You can catch errors. Now, this here is the class keyword. We're making a special class, and this is right from the eloquent JavaScript example. But you can define your own classes that inherit via the prototype business from another class. And the way you do it with the magic class keyword, I didn't even mention this, but you use the word extends. This means this is the same as the colon when we were looking at the C# example. It inherits from this class. And this is one case where there isn't really a better way than here to basically, you kind of want to sometimes, if you want to make many different kinds of errors and handle them in different ways, you could say, if the message in the error is this, then do this. If the message in the error is this, then do this. But I think like a more standard way, or a more way that more people would recommend, and I'd probably say, yeah, maybe, is you just make a really quick subclass of error that is your own, my custom error. It can be whatever you want to call it. And then you can use a special operator called instance of in JavaScript. And instance of will look at all this error, all of this object inheritance prototype, blah, 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 blah. And it will say, was this object created by this thing, my custom error? And I don't have the other half of this example. I have to grab it from the book. Hold on. This is in the bugs chapter. Here we go. Oh, wait, no. Oh, yeah. Oh, wait, no, this is in my code example. Okay. So this was called in the book multiplicator unit failure. Sure, whatever. You can call it whatever you want, but you can make a class that inherits from the general error, the capital E error, and then check whether each error you catch is an instance of that and do some different things. Now, in this case, this is the code example that is in error classes. And this is right from the eloquent JavaScript book. This is actually the solution to one of the chapter problems. But this is like a hypothetical. Let's say there is a multiply function that takes two numbers, multiplies them together. But for some reason, whatever, in a random chance, 1 out of every 5 times, which is what this means, if the random number between 0 and 1 is less than 0.2, 1 out of every 5 times, it will work. Every other time, it will error. Now, this could happen for any reason. It could be an unreliable API call. It could be something that depends on, I don't know. This is generally not a good sign if your program is this unreliable. If it only works 1 out of 5 times, that's not good. But let's say there was some kind of problem that you had to basically handle. And rather than fixing it at the source, well, it's just going to fail like this when I try to do it sometimes. But it has a good chance of succeeding if I try it enough times. And who cares? We got to ship this code. So we're going to make it just retry until it works. But if it's not this known kind of problem, this exact specific kind of error class, so you've made a special subclass of error that's like my own kind of error. If it's not this particular error, then something else went wrong. And we really do want to just cause an error because we don't know what happened. That could be, so any other error should be a problem. But this one, this particular kind, we know we're just going to retry for this particular kind. So we could wrap this call into another thing. This one's called primitive multiply in the example. And here's one that's called reliable multiply. And it's only reliable because it just retries the primitive multiply until it works. And the way it does that is it tries to return the result of the primitive multiply. It catches errors that throws. Now, obviously, it throws this error most of the time. if, now it uses this syntax to say, if the error object that it gets back is an instance of this thing, which is our subclass of error, which we can use to make our special errors here, if it's an instance of this subclass, then we try again, and we do this by a thing I haven't even mentioned called recursion. This function is calling itself again and passing the same things. It's calling itself. That's a thing you can do. Usually when you think, aha, a clever solution to this is recursion, you might be wrong. There are not actually that many cases where you really do want a function that calls itself. But this is a clever way to say, retry myself until it works. So this function says, call myself, and just keep calling myself until it works. Well, so catch any other error. If it's not an instance of this, we're just going to throw it, and we're just going to throw it again. Say, wait, somebody else handle this error. We're throwing it again. And because you're throwing it out of the catch block, it keeps going. It'll go all the way up and crash your program this time. Unless it's the instance of this, in which case we're just going to retry by calling the same function again. This is a lovely way to introduce recursion, but again, maybe I think this might be touched on, and I don't know how many of you are going to use this to solve a problem. There might be a problem you get stumped on, and you'll come to an instructor and say, man, I can't figure out how to solve this one. And they'll say, boom, this is a perfect problem for recursion, but it's probably less common than you think. And it's kind of dangerous, because if this never worked, this would just call itself forever. If we just kept throwing the error over and over, this will just keep calling itself over and over, and that can be an infinite loop. But in any case, we're going to keep calling it until we don't get an error. We get this. This gets returned from either here or the first time if we get lucky, and then we can log it. So it will turn our multiply that only works 1 out of 5 times into one that eventually works every time, given long enough. Whoops. I'm still in my other. So this is node. And it's so fast. JavaScript is so fast that it will pretty much, you won't even be able to tell the difference. Now, let's say we, if we just threw it instead, in both cases, no matter what, it's the same as no if else, just we throw it instead, we're going to error most of the time. But because we keep calling this function until it works, it appears to work fine. Now, here's the problem though. What if this had a tiny, tiny chance of working, like 0.001, this is like 1/10,000th of a chance to work, I think. Or something like that. A very small chance. It's going to start taking longer. See that little pause? Still pretty quick. What if we make it even less likely? Now it's going to start. Oh no. Uh-oh. Maximum call stack size exceeded. You know what that means? It means this function called itself. Every time you call a new function, you're putting a new execution context onto that stack. Function. And we're so unlikely to get the result. We call ourselves so many times that rather than an infinite loop, I was wrong when I said it will run forever. Pretty much every program, if you have a recursion that never exits, it's going to crash with a maximum call stack size, because every call to itself is putting a new thing onto that execution context. Another function, enter another function. And so let's see. Let's see if we can get even that. So now sometimes it works and sometimes it hits the maximum call stack. Now, if it's 1 in 5, you're pretty much never going to hit that call stack, but you could get super, super, super unlucky and it would fail enough times for it to hit that call stack. That would be like probably like winning the lottery a couple times in a row though. Anyway, so that's a couple of things. That's showing you subclasses of classes, how to use that. Really one of the only places I can think that is a place I would say, oh, make a subclass of an error to do this. In other places, you can make a class-based React component, which extends some kind of parent, template for React components. I usually make the other kind of React component, but I think they'll be at least be mentioned. There is a class-based React component. So that's another case where you might encounter classes. I think Angular uses classes or Angular uses like TypeScript for everything by now, and TypeScript has classes, and but it would have that pattern too. I think, Karen, right? You mentioned that probably, but you'll probably encounter classes, and I don't like them. But for this case, for making special kinds of errors, I think it's probably the best pattern, partly because you don't have to put anything in the class. All you have to do is extend the error and make it a special kind of error. And that's how this pattern works. And then also showing you recursion. So a function that calls itself until it succeeds, basically. And it doesn't have to catch, it finishes this, it gets all the way to the end, and it returns it without crashing, without catching, without calling itself again. So that was a bit of a chunk of new things right at the end there. So sorry about that. But that's all I've got for today. I don't know if we really have time to mess with the card trick, but maybe we'll do it at office hours if there aren't other questions. Anything that you want to quickly go over before the 8:30, or should we call it? Reading is these 2 chapters. Homework is in Google Classroom. The homework is to use this file. It's in the same folder in W7D3. It's called homework. And the idea is just to take the end of this, we're running divide 2 numbers, and we're trying to divide by 0. And this is going to throw an error and crash our program. The homework is to move this and catch the error, and then upload your file where you've caught the error coming from here and your program doesn't crash. So that's the homework.
When do you want to do office hours?
Oh, I mean, I have no problem with 11 on Saturday again. If anyone has a time, needs a different time, let me know. And obviously, like one-on-one time is also fine too. So let's just say 11 on Saturday again. Yeah, unless something comes up and we change it, but 11 Saturday. All right, man, I don't want to start a whole new, but let's see, what's function recursion. A recursive function is a function that calls itself. Like, just quick question. Did anybody wonder that? Like, I wonder if a function could call itself. Because that's a surprising thing to most people, I think. It's like, what does that even mean? How does it know that itself is a function? Like, it's inside, but it's a real thing. Let's see, good uses for recursion. There are less than you would think. When should I use recursion? Yeah. Too complex for an iterative approach. Searching through a file system. Yeah, okay, so like one good case for recursion is traversing through some tree of stuff. So like if you have components, if you have like I don't know. Traversing through a tree. Like let's say like Twitter followers. If you wanted to trace through, like one person has all of these people following them, each of those people has another person following them, each of those people has another person following them, has other people following them, and it's this big tree. You start with one person, and you have this big tree of like everybody following their followers, and the people following their followers, and the people following all of their followers. If you wanted to search through that for one person, one possibility would be to say, check whether it's in my followers. Otherwise, run the same check on all of those followers, which will check their followers. The problem with that is it will quickly explode in complexity, and it will take like years or never end. It'll be like, if you have a big enough tree, this is a subject, it's actually very interesting, called computational complexity. And this is the theory of how fast your program is going to run in a very, very big picture sense. Like, will it ever finish? Or will it finish in time that I could scale this out to 1 million users? Or, that those kinds of questions. They're more advanced, like, questions you start to ponder like in a computer science degree and a master's degree or something like that. But those are some interesting, it's like time, is this strategy gonna scale to what I need it to? You don't need to worry about any of that for your capstone, because you can probably use the most inefficient strategies for everything, and you'll only have a couple hundred objects to work with, and you'll be fine. So anyway, just a cool curiosity. All right, I'm rambling on and it's overtime. So see you all tomorrow. Yep. See you, Carolyn. Any questions, put them in Slack. Have a good night. Thanks for your attention, your effort, everything, of course.